Okay, good evening. Today is week 2, Thursday. The agenda, we're going to look at centric unsymmetrical bending. And last Tuesday, we stopped at finding the orientation of the neutral axis. Then after that, we are going to go to eccentric symmetric bending. Then I believe I can finish this in like after the break, maybe another 10-15 minutes. Then if you have any questions with the homework, you can ask me, okay, and I'll do it live, okay. So we were going to determine the orientation of the neutral axis, and over here our structure is under centric unsymmetrical bending. So we were looking at the formula to apply to this structure, which is equal to stress X is equal to my over Iyy multiplied by z minus by mz over Izz multiplied by y. Okay. So what I want to highlight since Tuesday is the transformation. Okay, the transformation rotates with the structure. Okay, anything to remember, this is the most important thing. Okay, the orientation rotates with the structure. Why that is the case is because of easy or simple to acquire the Iyy and Izz. Okay, so rather than say the word acquire, calculate. Okay, so if you look on the left hand side, yeah, because the transformation is fixed to the structure, to find Iyy Izz is with depth cube divided by 12. Okay, so when you rotate the structure over here, okay, when you rotate, if the transformation were to fix to the structure, Iyy and Izz formula did not change at all. Okay, so remember this, the transformation or the values are the same. Okay, now that's the first thing to remember. So we want to find, we're going to locate or determine the orientation I'm not spelling well, orientation of the neutral axis on the YZ plane. Okay, we're going to determine the neutral. So by looking at the formula that we see at the neutral axis, we are aware that at the neutral axis, okay, stress X is equal to 0. Okay, and I will call this equation down here as our equation 1. Okay, so therefore equation 1 will become 0 is equal to my over Iyy z minus by mz over Izzy. Okay. Now, a lot of students ask me why my is positive in the original formula and negative down here. Okay. My only explanation over here is when you look at the transformation, right? Usually going up is what? Positive. Going towards the right is what? Positive. Yes or no? Right? If you look at if the center is 0, always going towards the right on the x-axis is positive, going up is positive. However, when we orientate our transformation in this view, right? So y is positive, that's why it's my is positive. Mz positive or mz z orientation now is going towards the left. Okay, so that is why it is a negative down here. Okay, so if you have to remember it that way, y and z is negative. Now, so we have the expression that at the neutral axis, right? Neutral axis is defined as at that along the axis, the normal stress is equal to 0. Okay, so from what we have written, so this is our equation 1a. We have the expression that we have my over I y y z is equal to mz over I z z y. Okay, so now let me sketch the transformation. Okay, let me sketch the transformation now. Okay, so now this is our z-axis. Okay, this is our z, and then we have our y axis. Okay. Now we are going to focus on this diagram that I'm sketching now. Okay, we're going to focus on this. Now we know that this is for unsymmetrical bending. Okay, we are aware that it's for unsymmetrical. So the condition to satisfy unsymmetrical bending is that you have moment. So this is the applied moment. Okay, so this is our applied moment. The applied moment, okay, has a orientation. Okay, now this is important. Starting from Z, it will rotate in this direction, and this direction is with what we call theta. Okay. So the moment vector, okay, the moment vector m will rotate, or the moment vector m rotation will start from Z axis. Okay, and an important thing to take note is how the direction, so you can see the direction how I've drawn. So for this case, right, you have to be careful over here. Negative, right? The angle is negative when the angle is positive. Theta is positive, right? Theta is positive when the rotation is clockwise. Okay, theta is positive when rotation is clockwise. Theta is negative when rotation is counterclockwise. Okay. Now remember, this axis over here, okay, these two axes over here, I'll use a different color. This axis over here, it will rotate together with the structure. Okay, always remember that it will rotate with the structure. So from here, we are also aware that there is two components. right? You guys, all of you will know this already. So there's two components. So one component is your mz, right? So this is your mz component, and then your next one is your my component. Okay. Okay. So from here, we are going to let theta or tangent theta is equal to my over mz. Okay, and we already declared this already, where theta positive is clockwise from z, and theta is negative when it's counterclockwise from z-axis. Okay, so with this in mind, right, we can now rearrange the formula or rearrange equation. I will call this our equation 1b. Right, we can rearrange our equation 1b, where, so from equation 1b, we can write my over mz will be equal to iyy over izz, right? Iyy over izz, y over z. Okay. So from here, we can write that my over mz is equal to, so we can write equal to tangent theta, right? We can write this expression where tangent theta is equal to iyy over izz, y over z. Okay. Okay. So from here, what we are trying to determine is the neutral axis. Okay. So I'm going to sketch the neutral axis. Okay. We are going to sketch the neutral axis now. And this is our neutral axis. Okay. So this is our neutral axis. Then let me elaborate this again. Now our neutral axis, again, the orientation is start from the z-axis. Okay. And then it will rotate in a clockwise direction. And this is our pi angle. Now let me, yeah, that is our pi angle. Okay. So again, I will write this down, that the neutral axis, the orientation of the neutral axis right will start from the z-axis, and then the same pi is positive when the rotation is clockwise, and pi is negative when the rotation is anti-clockwise or counterclockwise. Okay. So if we have a point over here, okay, if we have a dot over here, the dot will have a point, okay, will have a z and y coordinate points. And we know